Hi friends, welcome in my video lecture. I am Roshali Zado. Today we discuss on Schottky defect and Frenkel defect. This defect in a study in a crystal structure, in ionic structure mostly. Most of compound are divided into three types: a stoichiometric compound, non-stoichiometric compound, and ideal crystal. In stoichiometric compound, cation and anions are exactly in the same ratio. Their common example is NaCl, CS, chloride. Second compound is a non-stoichiometric compound. In this non-stoichiometric compound, the ratio of cation and anion differ from that indicated by their identical chemical formula. That means their ratio is a difference. For example, one compound is 0.99 and one compound is figure is 1, like that. The next third compound is a ideal crystal. In ideal crystals, regular order arrangement of ions in a crystal are present. That means there is a perfect arrangement of crystal. Now we discuss on defect structure. Defect means abnormalities, like that, randomness, like that. Firstly, we study defect in a stoichiometric defect. In stoichiometric compounds, cations and anions are same ratio, and in this compound sometimes defect randomness available. Stoichiometric defects means the perfect crystals are those which have definite arrangement of ions in them at absolute zero temperature, but as the temperature increase, some vacancies are created, that is, ions leaves their original place and occupy the same other place. In this known as defect in the structure. That means temperature increase, defect is present in this structure. Firstly, we study the two types defects in stoichiometric compound. First defect is a Schottky defect, and it due to the vacancies in a lattice. That means this defect is observed in when vacancies is present in crystal lattice. There are some characteristics. First characteristic is it is a form in a stoichiometric compound. Defects are formed in a stoichiometric compound. Second is it is due to the equal vacancy or holes at the lattice side in the crystal. That means in this equal size of cations and anions. That means vacancies or holes are available. Next one, there are the equal number of missing positive and negative ion in the crystal lattice due to the crystal remain neutral. That means when one cation loss, then also one anion in this loss. See the figure, cation, anion, cation, anion. In this anion, cation absent. In this cation present, anion absent. That means one anion, one cation, equal absenteeism of ions. It is occurs when there is a very small difference in the size of the positive and negative ions, and this defect is observed in a equal size of cations and anions. Their cation and anion ratio exactly approximately equal to the 1. Their example is NaCl, KCl, like that. And this effect is strongly observed in a strongly ionic compound and which have a higher coordination number. For example, coordination number is 6, and their common example is NaCl, sodium plus and chloride minus ion. And in this compound, in this defected compound, energy required is very small. Second defect is observed in Frenkel defect. It is due to the dislocation of the lattice. In this lattice, dislocation of cation or anion, and their characteristics are some. It is also formed in a stoichiometric compounds. It is due to the delocation of ions. Their figure is represented as cation, anion. In this anion, cation absent, cation dislocated in this space, in available space, because cation size is very small and it is fixed within this space. And this positive ion is occupied interfacial position. This is called as interfacial position, and this cation are matched in this position. In this compound, their cation and anion ratio is less than 1. That is, for example, silver bromide. This example of silver bromide, silver chromide, this is halogenated silver compound. This compound which highly covalent in their nature. It is found in a compound having a low coordination number. For example, silver halides are a low coordination number. Zinc sulfate also have a low coordination number. In this, defect is observed in this types compound, and in this Frenkel defect is energy required is a higher energy. That means in large form of energy is required. And in this all both defects, energy are short, energy are small in Schottky defect, and Frenkel defect, Frenkel structure, energy is high. In stoichiometric compounds or in ionic crystal compounds, only one defect is at a time available. Like that, one compound is shows Schottky defect, its absence absolutely Frenkel structure or Frenkel defects. One compound shows a Frenkel defect is absent as a Schottky defect. That means Schottky defect and Frenkel defect is a misarrangement of a cation anion. In short, Schottky defect is a equally absenteeism of a cation or anion, and in Frenkel defect is a absence of cations, and this cation is fixed in a interstitial space, and interstitial space is a like that is a square bracket of cation anion. These both are defects. It is a very easy and understandable topics. Thank you.